So hopefully you have watched some of these videos. I do encourage you to watch all of these videos because I've put them in for a reason. So first video explains how cosine rule kind of works, a bit more example, and then third one is about what the difference is between sine and cosine and how to figure out which one to use. Obviously, this section is going to be all cosine rule, but once you get to the problem solving part, you need to be able to determine which one you need to be able to use, sine or cosine rule. Pretty simple. There's just 3 different versions of it depending on which symbols you want to use. Basically, you should know how to label angles and sides by now. And basically what cosine rule helps us with is it relates 3 sides of a triangle when you know 1 angle. So it's you need to know those 4 key informations. It's not similar to sine where you have a complete pair of an angle and a side and a half pair of an angle and a side. You need to know all 3 sides of the triangle. You might not know one of them, like you need to be able to label them, and then you need to at least know 1 angle, or like you're trying to find the angle, etc. So for this example, as you can see, you're trying to correct 2 decimal places the length of BC. Now, rather than calling it length of BC, let's call it with an alphabet. Length of BC is this length over here, which is opposite the angle A, so we'll give it a little symbol A. So now you can hopefully see that we don't know A, but we have 3 lengths that we're working with, and we have 1 angle that we're working with. So we do know we need to use cosine rule. If you scroll up, you're trying to find A, so you want to use this equation because the unknown is by itself. So I'm just going to copy it down. If you use it enough times, you should be able to kind of memorize it, because if you kind of have a look at this, it's almost like a Pythagoras theorem. And then there's extra bit to it, which is just take away 2 times these 2 lengths, BC, and then cos of that angle, that opposite of the angle that we're trying to find, that length we're trying to find. So that's the formula. Hopefully you can remember it if you use it enough times. But let's start to fill in some gaps. So my B, if I label it, this one's B, this one's C. So let's give it a go. So B is 13 squared. It really doesn't matter which one. If you write 11 squared plus 13 squared, the order does not matter. So you don't really necessarily have to label it if you're a bit lazy. But anyway, so 13, 11, then cos of the angle 42 degrees. So if I chuck this all in the calculator, I'll get hopefully a decimal answer. But rather than doing that, I might just go, well, A will definitely be a square root of that, and then I might just write the whole square root version of it. So I always know what to put in the calculator exactly. So I'm just going to chuck that in the calculator now. This cos looks hard, but if you know the trick, if you know how to use it, it should not be hard at all, because it's just plugging in numbers. Alright, hopefully I have all the time signs right. So what I got is 8.80. So I'm going to write 2 decimal places. So that's what I got. And you write units, and there you go. Now, these are pretty much the same equation, but rearranged to find the angle, okay? So it's literally the same. You should be able to kind of see how it's rearranged. But I'm going to move on. Once we have these angles, obviously you do inverse cos on each angle to find the corresponding angle A, B, and C. So let's give this a go. In a triangle ABC, AB is 7 centimeters, BC is 5 centimeters, and CA is 8 centimeters. So find the measure of BCA. I might draw it to kind of help us out a bit. A, B, C. So my AB is 7 centimeters. My BC is 5 centimeters. My CA is 8 centimeters. It's a non-right angle triangle, I just assume, because we're doing cosine section. What I want to do is find BCA. So that's the angle that I'm trying to find. So BCA, that one. So I want to find the angle C. So I'm going to copy this equation down. So cos of C equals A squared. This one's A, this one's B, this one's C. A squared is 5 squared plus 8 squared. Take 7 squared. Make sure you have the ABC labeled properly, or you'll obviously get that one wrong. A times B, 5 times 8, So before I chuck that in the calculator, I might just inverse cos it, just because I don't like using the calculator much if I don't need to. Always the exact version is better than decimal answers in the calculators. So this is what I'm going to chuck in my calculator. Make sure you put in a fraction lines. Alright, so I get 60 degrees. So there we go, that's my answer, 60 degrees. Find the exact area of triangle ABC. Now you might go, how do I do this? Well, hopefully you kind of remember back to chapter 6a. You have a length and another length and an angle in between. So you should be able to use the area formula. Hopefully you remember it. Half AB sine C. Basically you just times half and the two lengths that are next to the angle, and then just go sine of 60. So you should be able to straight away tell me what the answer is by using the calculator. Hopefully you don't have to do too much thinking to get that. So I get 10 square root 3. It says exact area, and that's hence why I'm leaving it in that form. I could convert it into decimals. It's approximately 17.3 centimeters squared, but however I want to leave it in my exact form because that's what the answer said. So no need to write that. I'm just going to write my units and I'm done. So you should be able to copy all of those down. I want you to do these questions so we can move on. And I think that's it for cosine.